Hi, I'm Mark. Welcome to the Element 14 community. Today I'm going to share with you my stress level indicator. And basically the stress level indicator is a useful device, a gadget that you can use in the office. It has several lights that indicate the mood you're in. You can set it yourself, and each time the level changes, it plays a sound that you can program. What would you use it for? Well, just for, to ask the one question that everybody wants to ask in the office. Is today a good day to ask for a raise? Well, it depends on the mood swing of the boss, doesn't it? If he or she is in a very bad mood, then it's probably not a good day to ask for a raise. But if everything's peachy, then this might be the moment. So how do you know? Well, next time you take a look at the stress level indicator first. And if it's green, then you're good to go. But if it's red, I recommend you wait a few days. All fun aside, I'm going to show you how to build it. I'm going to include the mechanical drawings that I use for the housing. I'm going to include the schematics, and I will walk you through the Arduino code. Let me start with all the mechanical parts. I actually use a laser cutter to cut out all the acrylic parts, and first I'm going to glue them together. If you don't have access to a laser cutter, you can try finding a service online to do it for you, or you just design your own box, or maybe even buy a ready-made box and adjust it accordingly. That's totally up to you. These are all the parts we're going to need. Basically, it's the base plate, the top plate, the sides, and the little compartment studs. And of course we have a window, and this little window has some engraving on it with some text that will be visible later. So basically I'm going to apply a little glue. Don't use too much because you never know if it's too much, so just be gentle and apply more if needed. I only use a little, especially because this is a demo model. Of course I included a file that you can use for your own laser cutter. It's based on several thickness of acrylic plate, whatever is available. That's important because otherwise the dimensions will be different and will not fit perfectly. And that's 3. Now the last side panel. The glue I'm using is actually kind of universal glue this time, but it would be best to use acrylic glue. Unfortunately I run out, and for now this will have to do. Then of course we have the top plate, but I will not glue that in place right now because I still need to add the electronics first. Then we have these little compartment panels, which should go like so. And as you can see, there's a little space cut out. That's because I need to apply LED strip and cabling underneath. So that's where we're going to glue them, like so. So we'll have our own compartments. And now it's just a matter of aligning them to the markings that I already put in place. If we temporarily put the lid on top, we have a good idea about the alignment and whether we need to change it or not. When the glue dries, everything is solid enough and we still will be capable to take it out, to take off the panel to insert the electronics. And basically that's the whole mechanical part. Of course we will add the electronics and the speaker, the switch, the battery, the Arduino, etc. We will add that later. Now we just let this dry and we move on to the next part. Schematic can be divided into 3 parts. The first part is our Arduino microcontroller, which is an Arduino Nano. It's a nano board. It has some extra I/O pins in case I want to use it later. That's a habit I have, to always break out unused pins in case I want to do modifications or add extra functionality and I don't need to redesign a complete PCB. Basically there's a connection for the LEDs, the pixel LEDs, and there's a connection for the speaker. Of course it has a switch input and some data lines for the SD card. The second part is the SD card interface, which uses a level shifter because our Nano uses 5 volts as a power, while the SD card only needs 3.3 volts, so it has an onboard regulator that will provide power to the SD card. Okay, so the power supply is something specific. I will not go into detail how it works. I mean, I'm willing to do that, but that's something I could spend a whole video on doing. So if you're really interested in that, let us know in the comment or drop a note at the Element 14 community. I will see what we can do for that. But for now, basically what it does is when you connect a battery the first time, the regulator of the power supply is cut off by power because Q1, the transistor here, is not conducting. And as soon as you press the switch, it's overruled and the regulator will get power, and the Arduino will power up and take over that switch until you put it back to sleep mode. And since the switch has a double purpose, we also want to use it as an input. I added some extra components to make it possible. Again, if you want to know more about how this works, let us know in the comments at the Element 14 community, and we might do a video on that. Some of the things are optional. For example, the power supply is optional. If you don't need it, you could simply feed the Nano by the USB connector and leave out the whole power supply. The SD card, you do need to use the level shifter, so you might want to use a breakout board, or you can use one of those piggyback PCBs that has the onboard converter and you can just hook it up to the Arduino. I think there are some Arduino shields available that offer it, but that's totally up to you. And the easiest way would be to use the PCB, of course. So your components are pretty basic. We have a Nano Arduino, we have a speaker, of course we have a switch, a battery clip, a universal transistor NPN. I use the BC549. We have some pixel LEDs, and basically, although this is a whole strip, you only need 5 LEDs, so I'm going to cut off 5 single LEDs and wire them up with some wires. Then I designed a little PCB, and basically this PCB, it of course is optional. It would work fine because it has the holder for an SD card and it has an online power management. And the power management I used because I'm going to feed it by battery, and just putting an Arduino Nano board in a sleep mode will still drain a lot of battery. With the enhanced power module I created, that problem is solved. But it's up to you to use it. If you don't use it, you might have to make little changes in the firmware, but that's all doable. My first prototype actually didn't have any PCB. I just connected an SD card and basically speaker, and that was it, and it was working. What else do you need? You need some wires, of course some soldering iron and other tools, and you're good to go. So let's start building.
Do you like free stuff? You can join the Road Test program. You can get free dev kits, test equipment, and even online training courses in exchange for a detailed review. Join our Road Test program. Learn more at the link below. Free stuff.
Okay, so assembling the electronics. First we have our Arduino Nano. I'm going to attach that to the main PCB. The main PCB, of course, is optional. You can decide to not use it and use a breadboard instead, but you have to follow the schematic to make it work. First we're going to attach the Arduino Nano to the board and solder it, of course. You also need to solder on the transistor, and I prefer to use some header and sockets. Any standard will do, it just makes it easier to disconnect the wires later. To save us some time, I already did the soldering, and here's a version that has the header, the transistor and the Arduino on it. I will put both side to side for comparison. And basically that's all there is to it. So now we're going to apply the sockets and solder on the appropriate components. We'll start with the switch. And first I apply some solder tin on the connectors, because that will make it easier to attach the wires. So we're going to attach the black wire from the battery clip and the red wire. If you want to know how it's wired up, to find the right connections, take a look at the schematic. And of course we have the speaker. The only thing left right now for us to solder is the pixel LEDs, or are the pixel LEDs. And for that, let me take back the assembly of mechanics. Actually, when you take a look at the lid of the housing, the cutout area here is something I saved. And there's a perfect mold for assembling the pixel LEDs, at least to determine the wiring. So basically they're going to be placed approximately like so, and all I need to do is wire it up. Make sure you take a look at the arrow on the little pixel LEDs. There's yeah, that's hard to see here, but I'm sure if you take a look at the version you have, there's a direction arrow, and the arrow points out the input and the output. Of course, the flow goes from in to out, so the direction goes in this case from left to right. Left will be our input, and the output in the end we will not use. I already installed the pixel LEDs. As you can see, I cut them up, the pixel LED strip, I cut them up in individual LEDs, and I glued them to the bottom using the adhesive tape on the back, and I just connected them again with individual wires. And at the beginning of the pixel LED string, I attached some longer wire with a connector that I can just slide into our PCB. So with the last component in place, I can pull out the battery and connect it and see what happens. Now, when I press the button, it switches on. And that's all there is to the electronics. Now, once you start the EDA software, the Arduino EDA, you open the file. The sketch is made up of one single file, stress indicator, and you open it up and you can look at some parameters. There is one parameter you might want to change, that's totally up to you, which is the interval time. It's called delay val, and it's the number of milliseconds before it falls back to the previous stage. So right now it's set to about 3 minutes. If you want to make that faster, you can just change it before compiling and uploading. One thing I need to point out are the audio files, 5 for going up and 3 for going down, so 8 files. And each file that is played going up a level has a straight number, 0.wave, 1.wave, 2.wave, 3.wave, 4.wave. But the ones going down use an extension letter B, so 0b.wave, 1b.wave, 3b.wave. And that's basically it. It's important that you use audio files of a specific format, which is 8 bits, 8-bit audio files with a sample rate of 16 kHz mono. Other files will not work. It's as simple as that. I also need to install a few libraries. There are 3 of them. The links are in the firmware, in the sketch. And just install them and you're good to go. And then you press compile and it will start compiling. When you do, make sure you have the right board selected. We're actually compiling for an Arduino Nano, and the one I have here uses an old bootloader. Select the right one for you, and that's it. You press upload and it will upload the file and you're good to go. That's it. And that was the ready sound. That means this is the first sound played on stage 0. Of course you can change that sound to your liking. And that's all there is to it. Have fun. Okay, so I already attached the pixel LEDs. I used the adhesive glue on the backside of the pixel LED, and each LED in its own compartment. The PCB and the battery are attached with some double-sided scotch tape. And remember, if you're going to place this, you need to be able to plug in your USB to program it, and you want to be able to take out the SD card in order to put your sound files on it, and over time you might want to change it. That's all there is to it. And then you close it up. And remember that you want to be able to change the battery over time. So I wouldn't glue it up. Basically what I'm going to do is just apply a little piece of scotch tape both sides, and since it's see-through you hardly notice. Now, how does it work? It's simple. You press and hold the button until the first sound appears and the light goes on. Now the first compartment is all green. Of course you can change those colors in the software. And it says relaxed. If I press it again, it will play the next sound and I'll move on to the next stage. In this case, still calm. We also have an angry stage. We also have an on edge stage and a mad stage. Automatically, due time, after a few minutes, it will fall back to the previous stage and play a different sound. All sounds you can program yourself. If you want to turn it off completely, press and hold the button, and after a few seconds you let go, it will switch off automatically. Again, it will also switch off automatically by itself after a few minutes when it passes the last stage and it goes back to 0. That's basically it, my stress level indicator. I hope you have fun with it, and I would love to see how you apply it in your office. Maybe you can go to your manager or your boss and say, boss, I want a raise, and to know if it's ready, I'm going to give you this box. So you build it, you give it, and you ask for a raise afterwards. Would love to hear the outcome. Tell us all about it at the Element 14 community. If you have any questions or you need help completing the project, or maybe if you have suggestions for upgrade, would love to hear it. Drop us a note at the Element 14 community project page, and I try to answer each and every comment. This is all I have for now. I see you next time.